Hello guys, we took last lecture how to add two decimal numbers, input them from the user and add them. We had a problem. If we add two numbers like 7 and 9, we get 16, but we can't print 16 because we can only print one character when we use the move AH2, which is to see out, which is here. This is the last time the code we took. When we use this to print, we can only print one character in ASCII, and we subtract it. We added this to print it in decimal format. Let's now do the same code, but how can we? Let's show you the problem first. Let me show you the problem that happened in the previous code. If I say mount, I'm mounting to my assembler, and hopefully later on we're gonna start using the 615 assembler. I just wanted you to get you familiar with as many tools as possible. So now our program was program formula, and this is from the previous lecture, previous video. MASM program for new.asm, and we link it. Sorry guys. We link it to program for new.obd object file, semicolon, and now we run it. If I had 5 and 4, this is good, print 9. But the problem is, the problem is if I print, if I input let's say 9 and 8 and printed A. Why is A? Anybody knows what's A? Nine and decimal 17. So it took 17. But then remember, it only prints one character and it only reads one character. Can't read two characters. If you input 17, it can't read it. No, one character at a time. You can take it as a string. But what's A? Let's try to debug it. Always debugging is good, knowing what's going on in the program. Program for new.exe. Remember, U will show me the code, here's the code, and D will show me, this is in binary, this is the code, this is the whole code, the object code, and this is the data section on the right here. And now we're gonna trace the code. T will do the first instruction. If you can see at the bottom, move DSAX, that's the first line in the code, and each time we do a T, it does instruction or command. You can see the next command is move AH09. You can see how AX will change after this to 09. The high A high changed to 09. It was 07 in the previous one. Those will show you the output of all the registers, and we keep doing it. And let's see at the end, why is it giving me A? and it's gonna ask for input here. We're gonna have to put input when we debug it also. Here, see, it's waiting for input. I'll do 9. Where is the 9 gonna go to? Where did it go to, the 9? It's an AX. You can see it's 39. See, under the 9 register AX, it's 39. The ASCII value for 9 is 39. I'll show you the ASCII table in a minute. And it will save anything you input to AL. Anything we output has to output from DL. And this is move AL to BL. We can see how now BL is going to be equal to 39. You see, AX 139, BX is 39. But remember, AX is AH, which is 1, and AL, which is 39. And here's 09, this prints a string. Okay, this is loaded effective address, interrupt, STI, those don't worry about them, those are adding, finding the address. And enter the second number, and T again. This goes on the code line by line. And let's see here. We need to input another number, which is 8. And we can see now 38 in AX. 38 in AX. Why did BX change to 9? Because I stripped it from the 0. I took the minus 0, which is 30 in hexadecimal in the ASCII. So 8 is 38, 9 is 39, 0 is 30. That's why we subtract 0, so we can get the 9 and 8. So now we do the same thing. We did the subtract the 0, and this is what actually is going. Sub AL 30, 30 meaning 0. We had it as 0. And at the end we added them. And here I'm adding AL and BL and saving it in EL, in AL. So I'm adding 9 and 8 decimal. Here I changed them to hexadecimal. What did it give me? 11. Who knows why 11? Who knows why 11? Think of it. 9 and 8 in hexadecimal is 17. What's 17? 17 is a carry of 1, which is the F, the 16, and 1. So actually it's 1, 1. That's why we said you have to learn the hexadecimal. It's really important. So it's 11. And what did it print? 11 is B. But printed A. Why? Here we add 30. 30 is what? Makes the DL now 41. You can see in DX 41, and 41 is A. It should be A. Okay, let's quit this and check the ASCII table. and this is called, the hexadecimal is called binary coded decimal. So if you read about the instruction AAA, it's going to tell you binary coded decimal, meaning hexadecimal, meaning it represents it as those values. Here we can see the 0 here is 30, 8 is 38, 9 is 39, and we subtracted, so it came out to 17, which was 11, and then we added 30, it came out to 41. 41 as hexadecimal as the letter A, and it printed A. We can see in the output. Nine and 8 printed A. It's right for the computer, but it doesn't make sense for us. But now you get why. So now we need to fix this problem. It doesn't happen when I add when my result is less than 10. When the result is less than 10, there's no problem. So now we're gonna use a command called AAA, ASCII, adjust ASCII after addition. Adjust ASCII after addition. The command AAA, and I just want to copy this code, the easy code, and we will rewrite all the other code. It's not gonna differ that much, but I like to do it from scratch. Begin. And here we just define the 3 strings, enter first number, enter second number, and first thing we said, we move the address, add data, where the data segment is, we move it to the data segment register. But I can't move immediately to DS, it's not allowed it in a move instruction. We can't move immediate to a data or to a segment register. So we move it to AX, then we move it back to DS. And now we can, now I need to print what? Move the string AH using 9 or 098, and I'll say load effective address DX and string 1, and we set this equal the same as move DX offset string 1, same thing. We do this. Now we say interrupt 21H, call the DOS, call the kernel to take care of the inputting. So now I input. How do I input? I use the move AH, what system call 1 is the input, and it inputs it NAL, and I call interrupt 21. I call the DOS to do the input, and now I do again. I move AH. I print the second message 9, and I can use. I don't want to use the load. I want to use move DX offset. I can use the load, but I just want to load the effective address, and I call the DOS to do the printing and interrupt 21H, and now I'll input the second number using a CN. Let's say this is CN, integer 21H, call the DOS to do that. Okay, but now let's move this to where? To BL, because I'm doing another input and it's gonna do it, but input it in AL, so I lose the first value. And we converted them to zeros. Now I don't want to convert them to zeros because I'm gonna use the AH1. Okay. Now I'm gonna print the result, which is saying move. I want to print the message saying the sum is, so I'm printing a string AH909 and whatever you want to put it, and I'm just gonna say load effective address, and I'm gonna use dx and string 3, and the strings are here. You can see that. Oh, you can see them here. That's string 1, string 2, string 3. First number, second number, the sum is. And now I'll say interrupt 21H, calling those to do the interrupt. And now I can add, I'll say add AL and BL. And let's say I inputted the first number, which is BL, as 8, which is 38 in hex. Remember, it takes the 8 as a character. 8 as a character, if I check the ASCII table, it's going to be 38. Where's 8? 8, it's going to be 38. In the previous one, we subtracted 0, so we can. So this is 38. And the second number, let's say 9. So it's going to take it as 39. So now if I add those in hexadecimal, or they call it binary coded decimal, but BCD 39, those are base 16. So if I say 8 plus 9, it's going to be what? 17, which is 7, and a carry of 1, and this will be also 7, so the result will be 7, 7. But what if we added them as binary? Well, we'll have, what's 38 in binary? The 8 is what? 0, 0, 0. This is 1, 2, 4, 8. And the 3 is 1, 1, 0, 0. This is 8 in hexadecimal, and this is 3. Now here, the 39, we have 0, 0, 1, 1, and we have 1, 0, 0, 1. This is the 9. And if I add them in binary, what are you going to get? I'm going to get 1. It's adding in binary. And this is 0. I'm doing it in reverse, so. And what's going to be the third one? 0. And this one is going to be 10, which is 0 and 1 overflow. This overflow is going to trigger something. Now I have 1, 1, 1, which is 11. This is what I mean by 11, and 1 overflow. And 1, 1, 1 is going to be 11 also, and 1 overflow. And this is going to be 1, and this is going to be 0. So did it give me 77? No, what's this? This is 71. This is 1. And this is 7. This is 1 and this is 7. And if we run the program, this is what we're going to see in AL. In AL. And let's run it and see what's going to happen. This is the best way so you can know it. Let's comment those parts so you can. And here, how do I end it? I'll say move AH4 ch to exit end process, and interrupt 21h, and here end begin. I think I put it, yeah. So let's save this as program 5. So let's debug it. I want to show you. Always debug is really good. It's your friend. How do we create the command? CLS. Okay, so we want to do MASM Program 5.asm unable to open input file. Sometimes they have to close this and open it because we created this after. Let's check. And we're gonna mount C to where my assembler is, home gate 8086. But you have to remember there's this converter in the 8086, but I'll show you that also later. And we'll do this, and now we'll do MASM Program 5.asm. One warning error. Well, it didn't even say it. Warning, extra characters online, and it's 9:32. Okay, we didn't comment this part. But it's not gonna do, but I would prefer having it. I didn't save it. On warnings, I'll do link program 5.obg semicolon, and I'll do, we can do directly to go to directly to debug and program 5.exe, and I want to trace the code. T, first command, I don't want this one, I want when we input the input is going to come now. And we said 9. See 39 now in AX. We have 39 in AL. The 01 in AH doesn't matter. No need to worry about it. T. We move this to BL, so now BL is going to change to 39. You can see it. Now we're calling the right string again, but let's go to the input of the second number, which is going to happen now. And we input 8. So now we have 38 and AL, 39 and BL. We have both our numbers, and we did the addition. Here we're just printing, this is printing the third string, and our addition is, should come now. Add AL and BL. I'm adding 38 and 39. What did it give me? It's going to save it in AL, which is 71. 71 in hexadecimal. So when you do print, what is it going to print? Let's quit this. It's going to print. Check the ASCII table. What's 71? It's going to print my letter G. Oh, that's good. 38, 39. It's going to, oh no, hexadecimal. It's 71. It's Q. Small letter. Q small letter. 71 hexa. So now how to solve this problem? We're gonna use the command which doesn't take any operand, AAA. ASCII adjust after addition. And what it basically does, when we have a carry or overflow here, it adds a 1 to where? To AH. It looks at the first 4 bits. Whenever we have an overflow of 1, or we have greater than 9, this is what? Greater than 9 or overflow of 1. We have here an overflow of 1. It adds 1 to where? To AH. So let's see this while debugging. And here's the first input 9. Oh, those are the string, and it's going by the code one by one, line by line. Now we're gonna input 8, and we're gonna see what does the AA do to the value. Ooh, I needed to put AH equals 0 before doing AA, but no problem. Check now. Here we did the addition, so it's gonna save what? 71 in. Oh, I didn't save it also, so it didn't take it. So that's good. So we go back and change it to let's make AH equals 0. Move AH 0, and we can use a better thing, and we can do, which takes less clock cycle, less time, let's say, XOR AH with AH. This will make it 0. XOR. Remember an XOR? And you can do that. I'm not going to do it. So now we do save. And we need to compile the program again. MASM Program 5.asm, and we link it. Program 5.obg, and now we debug it. I just want at the end to, I just need to input the values. Be careful. This counts now. It should after this one. Now 9. Eight. Now it's going to do the add. 1 minute, I'll show you the add. You can see the command, the last line in the middle of the stream, move AA00. I just want to get rid of the 9. And we got rid of the 9. Now I have AL and BL 38, 39, which is the 9 and 8. I add them both and save it in AL, which is 71. Now I call the AAA, adjust after ASCII adjust after addition. What happens? It gave us 107. 107. So we took the overflow where to AH and it gave us the 7. So now I have an AL 7 and an AH 1. And it's what? It's 17. Now if you print AL and print AH, it's going to give me 17, which is what? The 1, 7. 9 plus 8. Now what did I say we need to do? AL has the 7. So to print it, I'll do move AL to where? To DL. Oops. And I'll, how do I print? Move AH, and what we don't want to use, lose AH. Okay. No, let's move AH first. Let's print AH first. Yeah. And I'll move 2 to print. And I'll call interrupt 21.8. Do the same thing here. Move to DL, AL, and move to print AH. And I need a system call 2. And now I'll call the DOS integer 20 or the kernel. Call it the kernel, whatever you want. And this should work now. This should solve the problem in the previous example. Now we have another problem. What if I want to input a number greater than 10? We're going to need to do something similar, but how can I do it without having an add? We did this using an add. And that we're inputting, we're not adding. Here we added those. This is ASCII adjust after addition. So in the next program, we're going to show you how that works. Did I save? Oh, I don't think so. No, save. So MASM Program 5.asm. No errors, awesome. Link program 5.obg. I didn't put a semicolon. If I had put a semicolon, I want to go through those 3. And now I run my program, program 5.ex, or program 5 will work. What's our problem now? I've got to do one thing. What happened? It went and printed Let's go to the ASCII table. The 7 and 1 here. In the ASCII table, what's 7 and 1? Here's the 7. That's the 1. Start of heading. So it's nothing, that's why it gave us faces. What do we need to print? I need to print 31. There's two ways to do this. Two ways to do it. Either here, we can what? Or the AX with what? 30, 30 hexa. Adding 30, 30 to each one of them. That's one way. And this is the easy way. Or we can do add, let's say to DL after, or AH, let's say, before I move it to DL, add AL, we do a 0, and we do the same thing to add AL the 0. You know what we did last time too? 30 what? 30 0 0. Here we're adding 0 0. We're ordering it. We're adding 0 0 to AX. So it's the same thing. To give me 31, this is going to be 107 we had. If you remember. 107. So I add 1 here is going to give me 31. I add 7 here is going to give me 37. So I go to the ASCII table and check what's 31. It's 1. And what's that? It's 37. And now this should work. I always forget the semicolon. Program 5. I didn't save it. Say something, guys. Let's do clear. MASM. And now we link it. Link program 5 OBG and semicolon, and now we run it. Just print the name of the program, program 5, enter 9 8. The sum is 11. Why is it 11? One. Let's debug. Always debug. Maybe that didn't 30 each. That's right. Let's see what's going on. Nine is 39. And here's 8. So now 38, 39. Where did I do that? AL plus BL. Okay, 107, and now I XOR it with there 31, 37. But I printed AH, so there's no problem with it. I moved it to DL, so that should have given me a 1. Okay, here something changed. AL to 31. SI and BX. So to stay in the safe side. Okay. Let's stay in the safe side and do this. Instead of moving I'll move AX to BX. I'll move all of it. And now I'm saying here, move AH to BL. I'm going that way just to show you how. And here I'll BH, and here I'm moving BL, and this should work. Did I save? Yes, I did. Link program 5.obg. Now guys, you think of it, how can I input like 17 and 22? How can it take it as two numbers? So run 9 and 8. Here we go, 17. Run it again. Oops. So it's working good. But try guys to do it by yourself. How to input more than one digit. Here we outputted more than one digit. The problem is the CN or the Cout in here where we do it, the input, standard input and standard output. It does it as a character, as one ASCII character. So when I do A8, move AH1, which is standard input, it only takes one character. When I do move AH2, it only takes what? Output one character. And we saw how the addition here goes, binary. Remember, this is adding in hexadecimal. But think of it, 9 and 8 is 17. What's 17? 17 is 1 and 1 overflow. and this is the 7. Why? 17 minus 16 is 1 when I have base 16. You have to know the binary addition and subtraction. Binary addition, not binary, hexadecimal. Hexadecimal addition and subtraction. But here it does it in binary, and we can see in binary how they give me this result. Remember, those are hexadecimal numbers, base 16. Check the code. If you have any questions, please let me know, guys. I'll add the code in the description below. And next time we have to input more than 2 numbers. We did more low-level low-level assembly programming. Next after the next one, we go back to MASM using the Airborne library, which is a little bit easier. But guys, remember, if you know this low level, if you're a professional in it, it's a really big plus. If you're a computer scientist, remember, it makes a big difference. It makes a big difference. So it's up to you. It's not hard to learn. First you're gonna think it's hard, but go over it once, twice. Remember, repeat. Einstein, 99% depends on practicing, experience. 1% depends on smartness. So guys, do it, please. What's the harm if you watch the video 3-4 times? So thank you, and see you next.